965 out of 1,067. That's not a typo, and it's not a Tesla press release. It's a number from California's own Clean Truck and Bus Voucher Program, the state's official incentive database for anyone buying a heavy-duty electric truck. Between January 2025 and February 2026, out of every application submitted for that voucher, 90% of them were for one single vehicle: the Tesla Semi, Daimler, Packer, and Volvo, three of the biggest truck manufacturers on Earth. Companies that have been building Class 8 trucks since before Tesla existed, combined for fewer than 100 applications between them. That's not a rounding error. That's not a niche EV crowd chasing a novelty. That's the beginning of a shift in an industry that moves almost everything you own, and almost nobody outside the trucking world has noticed it happening. So today we're going to unpack exactly why that number exists, why diesel trucking has been so hard to displace in the first place, and what Tesla actually had to solve, technically and economically, to make fleet operators choose an electric semi over the thing that's powered global freight for a century. The skepticism is fair. Before we go any further, it's worth saying plainly, electric trucking has failed before, publicly and expensively. Startups have promised hydrogen and electric Class 8 trucks for years and delivered fractions of what they claimed. Range anxiety is real. Charging infrastructure for anything heavier than a passenger car is still mostly theoretical in large parts of the country. And diesel engines aren't stupid technology. They've had 100 years of refinement, a fueling network on every highway exit in America, and mechanics who can fix them in every town with a population over 1,000. So if you're skeptical that a truck can outcompete that overnight, you should be. The interesting part of this story isn't that electric trucking suddenly became easy, it's that Tesla had to solve a problem that's brutally specific to heavy trucking, one that has nothing to do with range and everything to do with weight. Weight is money. Here's what most people outside the freight industry don't know. A Class 8 truck in the US is legally capped at 80,000 pounds total. That's the truck, the trailer, and everything inside it combined. Every pound the truck itself weighs is a pound of cargo it can't legally carry. A diesel engine and its fuel tank are relatively light for the energy they store. A battery pack big enough to move an 80,000 pound rig hundreds of miles is not. For years, that was the quiet, unglamorous reason electric semis struggled to matter commercially. Even if the truck could physically do the job, it often had to sacrifice several thousand pounds of paying cargo just to carry its own battery. For a freight company, that's not an inconvenience. That's a direct hit to revenue on every single load, every single day for the life of the truck. This is the problem that killed electric trucking's business case long before charging speed ever entered the conversation. The solution, and its own flaws. Tesla's answer came from two directions at once, and neither one is flashy. First, engineering. The Semi's battery pack is structural, meaning it's built into the frame of the truck rather than bolted on as a separate box, which saves weight compared to a conventional design. Tesla has also continued trimming mass out of the 2026 production version, cutting roughly 1,000 pounds compared to earlier prototypes. Second, and just as important, Tesla lobbied for and secured a federal weight exemption specifically for electric commercial trucks. Extra allowance built into the weight cap to offset the battery's mass. Combined with the engineering weight cuts, that exemption is what finally gets the Tesla Semi close to genuine payload parity with a diesel Class 8 truck. In plain terms, for the first time, a fleet operator can put an electric Semi on the road. That doesn't mean the problem is fully solved. The Semi still can't match diesel's range at maximum weight over the longest routes. Competitors are already circling. China's Windrose has unveiled a similarly aerodynamic center-seated truck undercutting Tesla on price, and BYD's 8TT is expanding aggressively with competitive charging speeds. And Tesla's own charging network for trucks is still tiny compared to the number of diesel pumps in the country. This is a real advance, not a finished victory. What fleets are actually seeing? So does the economics case actually hold up outside a spec sheet? This is where real-world pilots matter more than any marketing claim. DHL ran a fully loaded Semi on a repeated 390-mile route and logged efficiency in the range of 1.7 kilowatt hours per mile. Reported figures nearly 10% better than that. Freight company Saia ran the truck across 2 shifts a day and consistently covered around 465 miles on a single charge. On cost, the gap is not subtle. Running a Semi on off-peak depot electricity works out to somewhere around 15 cents per mile. Diesel, depending on fuel prices, typically runs somewhere between 45 cents and 70 cents per mile, and spikes well past that when fuel prices rise, which they periodically do, hard. That math is exactly why the order book looks the way it does. WattEV placed an order for 370 Tesla semis worth roughly $100 million, the largest single electric truck order in California history. Port operators Big F Transport and Nika Container Freight Line jointly ordered 60 more. UPS, PepsiCo, and other major fleets have been in the queue for years. None of these are small companies experimenting for good publicity. These are freight operators whose entire business model depends on cost per mile, and the math is telling them to switch. What fleets are actually seeing? So does the economics case actually hold up outside a spec sheet? This is where real-world pilots matter more than any marketing claim. DHL ran a fully loaded semi on a repeated 390-mile route and logged efficiency in the range of 1.7 kilowatt hours per mile. Less than truckload carrier ArcBest, running the semi in its ABF freight fleet, reported figures nearly 10% better than that. Freight company Saia ran the truck across 2 shifts a day and consistently covered around 465 miles on a single charge. On cost, the gap is not subtle. Running a semi on off-peak depot electricity works out to somewhere around 15 cents per mile. Diesel, depending on fuel prices, typically runs somewhere between 45 cents and 70 cents per mile, and spikes well past that when fuel prices rise, which they periodically do, hard. That math is exactly why the order book looks the way it does. WattEV placed an order for 370 Tesla semis worth roughly $100 million, the largest single electric truck order in California history. Port operators Big F Transport and Nika Container Freight Line jointly ordered 60 more. UPS, PepsiCo, and other major fleets have been in the queue for years. None of these are small companies experimenting for good publicity. These are freight operators whose entire business model depends on cost per mile, and the math is telling them to switch. How Tesla is actually building these, the Semi is now rolling off a dedicated 1.7 million square foot factory in Nevada, sitting directly next to Tesla's existing battery gigafactory. Not a coincidence. The battery cells are made on site, and the structural packs are assembled and mated to the truck frame in the same campus, which removes a supply chain bottleneck that delayed this program for years. At full capacity, that factory is designed to build 50,000 Semis a year. Realistically, most analysts expect deliveries somewhere between 5,000 and 15,000 trucks in 2026 as production ramps gradually rather than all at once, which is normal for any new heavy vehicle line, electric or not. Charging is scaling in parallel. Tesla's Megacharger delivers up to 1.2 megawatts, enough to restore about 60% of range in roughly 30 minutes, timed almost exactly to match the federally mandated rest break every truck driver already has to take. Tesla has partnered with Pilot Flying J, the largest truck stop operator in the country, to begin rolling Megachargers into travel centers this year, with a target of over 60 sites across 15 states by early 2026. And replacing a fleet is a multi-year capital decision, not an impulse buy. Competition is real. Cheaper Chinese trucks, established manufacturers with decades of service networks, and a charging build-out that still has years of work ahead of it. But that California voucher number, 965 out of 1,067, isn't a marketing statistic. It's fleet operators spending their own capital, voting with real purchase orders on which truck actually makes financial sense today. Diesel didn't lose that vote because of hype. It lost it because, for the first time, the math on weight, range, and cost per mile finally lines up against it. Whether that number holds as the field gets more competitive is the real story to watch over the next few years. But right now, in the one market with hard public data to check the claim against, diesel isn't just behind, it's not close.